There's no way to say this song's about someone else. Every time you're not in my arms, I start to lose myself. Someone please pass me my shades. Don't let them see me down. You have taken over my days, so tonight I'm going out. Yet I'm feeling like there is no better place than right by your side. I had a little taste and I only spoiled the party anyway. Cause all the girls are looking fine, but you're the only one on my mind. La-di-dee, la-da-da-do, la-da-da-me, la-da-da-you. La-di-dee, la-da-da-do, there's only me, there's only you. La-di-dee, la-da-da-do, la-da-da-me, la-da-da-you. La-di-dee, la-da-da-do, when you were gone I think of you. All this place is packed with people, but your face is all I see. And the music's way too loud, but your voice won't let me be. So many pretty girls around, they're just dressing to impress.
Aiyo, so late one. Almost time already. Aiyo, finally you are here. Come on.
You know what? I passed by the route for 3 times. It's the same place, and the route is for going to the tailors in
3 times?
Yeah.
Aiyo, you should have used GPS.
I thought the route I know ma.
Okay, now no time already. Let's go orientation.
Sing a happy song.
Wait, today orientation day quite good now. Quite interesting.
That's all I can say. It's
Next
okay,
time?
you know. You
Got
probably
where?
this one.
Oh, next time jio me ma.
Joe, you.
Hey, but you should have come earlier, you know. Because earlier got more like time. Well, use GPS and you won't be late lah. Then you'll see much more like time.
By the way, what's GPS?
GPS? GPS. Let me show you.
What is GPS? GPS is Global Positioning System. It is a worldwide radio navigation system that formed from 24 satellites and their ground station. GPS uses these man-made stars as reference point to calculate position accurately to a matter of meters. These days, GPS is finding its own way into boats, planes, cars, and even laptops. You name it, GPS has it.
The basis of GPS is triangulation from satellites. But purists would not call what GPS does as triangulation because it does not involve angles. It's actually trilateration, which is a method of determining the relative position of objects by using the geometry of triangles.
To triangulate, a GPS receiver measures distance using the travel time of radio signals. To measure travel time, GPS needs very accurate timing, which it achieves with some tricks. Along with distance, you need to know exactly where the satellites are in space. High orbits and careful monitoring are the secret. Finally, you must correct any delays the signal experiences as it travels through the atmosphere.
So you may be wondering, how does the GPS know where we are on Earth? Well, the whole idea behind the GPS is that they use satellites in space as reference point to track down our location on Earth. Yes, by very accurately measuring our distance from satellite, we can triangulate our locations on Earth. So why triangulate? Because we need 3 satellites to do the job for us. So in the triangulation method, say that our distance from satellite A is 10,000 miles. So we can be within the 11,000 miles radius of satellite A. And then by measuring our distance from satellite B, we find out that we are 11,000 miles away. So we can be in this radius. You can see that these 2 circles actually overlap. Therefore, the possibility and the area or region that we are located on Earth narrows down to this region of intersection. When we use the third satellite and we found out that our distance is say 13,000 miles away, there will be another point of intersection. So this is the region of intersection, and our location will be narrowed down to just 2 points, which are here or here. So to know which one is our real location, right? Well, usually one of these 2 points are just too far from Earth and can be rejected without any measurement. That's how a GPS finds out where we are located on Earth.
Okay, as Min mentioned earlier, the GPS system measures our distance from Earth to the satellite. Okay, the satellite is always transmitting waves that contain information of the position of the satellite and the time that the satellite is at that moment. Distance is measured by the formula speed multiplied by time, where the speed is actually the speed of the waves transmitted by the satellite. These waves, the speed of these waves are actually the same as the speed of light, that is 3 times 10 to the power of 8 meters per second. Whereas time is the time taken for the wave to travel from the satellite to the receiver that is on the Earth. And hence, time is a little tricky because according to Einstein, there are 2 theories that are related to time, that is general relativity and special relativity.
By general relativity, high velocity object will travel at a slower rate in time. By theory, satellite will travel approximately 7 milliseconds slower every day, 6.73 milliseconds to be exact. By special relativity, states that the weaker the gravitational field, the faster the time. So, time on the satellite will be faster by 42 milliseconds per day. Don't ask me why. Difference in time on the satellite will be, don't copy, understand first. 42 milliseconds from the special relativity, 7 milliseconds from the general relativity. The result is 35 milliseconds faster every day. Understand, class? Throw your questions at me. What do you mean you don't know distance? Don't you have done your homework yesterday? Alright, I will explain it one more time. By getting distance, which is speed times time, from the speed of light, which is 3 times 10 to the power of 8 meter per second times 35 milliseconds, bingo, you get a distance.
Oh, now I know what's GPS.
So next time when you use GPS, need to remember it's all thanks to the power of maths.
Yay! So, you might be wondering, how does a GPS know our location on Earth? So here I'm going to explain this method of